You must have heard about this TCP, UDP, and QUIC in some notebooks or in your textbooks. But do you really know that these things can be integrated with your code as well? And not just to like anything, but there are some classification of applications in which it is specifically declared that you should use TCP, UDP, or QUIC. So let's understand these all the things in this part where I'm going to teach you the system design. It's a system design course, and let's start. So we will start with the TCP, then we will move to UDP, then we will move to QUIC, and then we will compare it, and then we will see its uh, code as well, like how you can integrate it, and then we will go for the interview questions. So let's start with TCP. So here, this TCP. Okay. Mhm. So here I have this TCP. TCP stands for, so this transmission control protocol comes when each data packet is precious. So let's say there is this user and there is this web server, and user is sending some data to the web server, and web server need to acknowledge it or save it or process it. It can be anything. But this data is very precious, and you cannot lose a single bit this data over the internet. Sometimes it happens that your network goes down, sometimes it happens that your web server is not responding properly, but this data transaction is so precious. And why I'm calling it precious? Because it can be your financial application where you are sending some money, or where you are going to receive some money, or you are going to create some schedule where you are doing the transaction. So this financial application like the banking or file transfer, also the file transfer. If any application is using the file transfer, it means you want to transfer the file as it is, as you have at your place. So these kind of application need a mechanism, a protocol where the complete data is transferred from user to web server and from web server to user. And what I mean by the web server, it means where the application is running. It can be anything. But for the TCP, we are referring as the financial application, file transfer application, anything like, but it need to send the data accurately. So this is the just one usage of TCP. But how it ensure that everything is going as it is, like the way we planned. So what I will do, I will start it from the basic, then we will go for the advanced one. Currently, we are going to look only for the TCP. We are not going for the TLS, that we will handle in the next part. Okay. So, okay, here I have this. Again, I will do the TCP. So in TCP, again, everything start from the user. So here is the user and here is the web server. Here is the web server. And for these two entities, we are going to use the word entities because it is a one entity and web server is the second entity. Between these two entities, if a data need to be transferred, then it is required, then they both know each other. Then they means both know each other. When they know each other, then only this internet will allow this user and web browser to send or receive data to each other. But how they will know each other, that's the one mechanism which we need to learn. Okay, so what I will do, again, I will click in the space. And now we will talk about the actual mechanism, how they first know to each other, then they start to transfer the data. So, okay, again, so here is the user. So everything start from the user. So again, we have this, okay, let me just change the marker. Okay, so we have this user And here we have this application which is running on web server. And currently we are talking about those applications which are using TCP. It means I'm talking about some banking application. I'm talking about the application which do the file transfer. So here's the user. So what the first user will do, user will send one synchronization request that is called as sync. This synchronization request will go to the application. What it will contain? It will contain this request plus ISN. What is this ISN? This ISN is the initial sequence number. And what is this initial sequence number? I will tell you the use why this ISN need to be sent to the application. But for now, we will assume that it is a variable called X. Actually, it is a random number which is sent by the user to the application. And currently, we are referring it as a X. After getting this sync request, now it's time for the application to acknowledge it. So after when application acknowledge it, application will send it sync plus acknowledgement data. Okay, so first the user will ask for the synchronization request, then application will acknowledge it, and application will tell the user, hey, okay, I'm fine with this, and I also want to sync with you. So right now, this acknowledgement, sorry, pink flow. This acknowledgement is for the sync, and this sync request is initially coming from the application to the user. So, okay, is the pen. Here is the pen. It will go to the user. Right now, again, it will send one ISN. This ISN will be stored at the user's end. Okay, and why? Again, I will tell you. But after completing this complete synchronization acknowledgement cycle. So right now, it is the sync request which went to application. This sync request also contain the initial sequence number, and we are assuming it as X. Right now, after getting it, the application is acknowledging it and also sending a sync request to the user with the variable Y. It is again ISN, a random sequence number, sorry, initial sequence number, but with a random value. It is not set. After getting this sync plus acknowledgement, again, this sync request need to be acknowledged. So what this user will do, user will again provide the acknowledgement to the application that, hey, okay, now we are good to go. So in this way, we did 3 steps. What are these 3 steps? First, sync, then sync plus acknowledgement, and then in the final, the acknowledgement. So it's a 3-way cycle to create a TCP connection between the user and your application, and it is all done by the internet. All you need to do is you need to define that your application is sending a TCP packet. Okay, so what here we have, it's a TCP packet, and TCP packet need to be sent to the application that we can configure in our application by code that I will show you later. But we need to understand it is the 3-step process. And okay, so it is the one thing. Now let's come to the UDP. Let me clean it. Okay, so here comes the UDP. UDP. It is for the user datagram protocol. Now, earlier, we were so much concerned about the data protection. We do not want to lose a single packet of our data. We were so obsessed with our data that it need to go anyhow. I do not want anything to be missed. So that is why the TCP was there. But then there were some application which actually don't need the complete data at the runtime. And what are those applications? Those application was the video streaming, video streaming, online gaming, These type of application are those application which are very focused on the thing which are happening at the current time. If anything get lost previously while streaming, while talking, that is lost because the user is so focused about the current implementation or current things which are happening in the application. So this UDP is using a very good method that is called fire and forget. Fire and forget. It means for the user, okay, let me create this one. So here is the user, here is the application. There will be no synchronization request or acknowledgement request. What this user will know that, okay, this application is running at this IP and this is the port which which this application is providing me. All I need to do is I just need to blast the data to the application. I just need to blow the data to the application and nothing else. It means fire and forget. I just fired the data to the application with the help of the IP and port, and then it's all up to application how that application is handling it. I do not care whether application even received it because there is no acknowledgement back from the application. So in this way, UDP, what it do? So in the TCP, there were three-way step to establish a connection for the user and to application. For the UDP, there is only one way, that user is sending data to the application or application is sending data back to the user. Both are just firing data and forgetting whether the data is received or not. Okay, so this is the UDP. It is the user datagram protocol and it is used in the video streaming or online gaming. Now let's come to the third one. Okay, let me clean it. What is the third one? Third one is QUIC. Third one is, okay, let me remove this one by mistake. Okay, the third one is QUIC. It is quick UDP internet connection. So this particular module was developed by the Google. Google is a very good company. It provided so many things to the software industry world that is just become a norm of everything. Okay, so that's a different thing. Let's talk about QUIC. So QUIC is the quick UDP internet connection. So earlier we saw that there is this TCP, which is so much obsessed about the data protection, data transfer. And then we found this UDP, which is very fast. TCP is slow because it is verifying the data. But QUIC, sorry, but UDP, it is not verifying whether the data is actually sent or not. It is just firing the data. But that UDP was very fast but unstable, and TCP was slow but stable. So what this QUIC did, QUIC said that, okay, I will use the UDP for its fastness, but I will create it reliable. So it is a reliable UDP. Actually, the QUIC is the reliable UDP. Let me clean it so that I can explain that how this QUIC actually works. There are lots of components in it. Okay, so for the QUIC, what happens is, so here is the user and here is the web server where your application is running. So when user send data or request to the web server, what it send that, hey, here is my data, but also source connection ID, source connection ID, and destination connection ID. But this data is not that data which I'm trying to send to the application, to this application, to the web server. It is the data, it contains some few things. What it contains? It contains the server initial packet number, which is usually 0. It is start from the 0. And what this source connection ID is for the user, it is the source. It can be seen as vice versa too. So this is the source connection ID. When this request went over the QUIC protocol, it provides the source connection ID where it provides the data about the user, this destination connection ID where it provides the data about the web server, and it also provides the data of the server initial packet number. So why we need these all things? So there is a very good concept behind it. So let me show you that. Okay. So here is the user again, and here is our application. So user will have some when we use the QU, just let me remove it. When we use the QUIC between these two, sorry for my writing, QUIC between user and application, it it actually create a stream of data. Okay, so it create a stream of data. So as I told you, this QUIC will send the data plus connection source connection ID plus destination connection ID. This data will contain the ID of the stream as well. Okay, so it is the stream 1, it is the stream 2, it is the stream 3, and so on. So there can be multiple stream as well. And why this concept was created here? Because when we were using the UDP or TCP, there was a single pipeline between the user and application. If something is sent between user and application, then there will be only one stream. But this QUIC provide me the mechanism where I can transfer multiple stream data parallelly. And why we need it? Because let's say if there are 3 files which you are downloading from the web application, if you are using UDP, sorry, TCP, if you are using TCP, then let's say you just click on the download button on all the 3 files. So first it will download the file number 1. Once that particular file number 1 is completed, then it will go for the file number 2. And after when file 2 is completed, then it will go for the file number 3. But in the QUIC, what happen is when you click on download 1, 2, 3, all the 3 downloads start happening in parallelly. It will not wait for the file 1 to get completed. If the file 2 is running parallelly, it will get download and completed, even though your stream 1 is downloading the data because of the large file system. So this data contain the stream ID, and this stream ID, this packet number, this source ID, and destination ID. These all things will be stored inside the application. Application will create a table where it will store all these kind of information. Currently, we are seeing the data transfer from user to application. But if application is sending data to the user, the process will be same. What is happening here from the user to application. So right now we have these all the things. So let's say we will talk a bit more about this QUIC so that you can understand why the QUIC is used by most of the application for the uh, better speed. Most of the AI applications are using the QUIC. So it's good if we know it. So right now, this user and application, they are connected to each other because user have sent some data from the data plus source ID plus destination ID. So right now, this application knows that, okay, there is this source there from where I will get the data. So there is a one scenario, let's say, in between the data process, something got failed. Let's say the user was moving, user was running, and there was some network issue. And in between the data transfer process, you got disconnected. In the case of TCP, this particular transaction will get failed, and you need to reinitiate the data transfer. But for the QUIC, what it will do, when your data line is broken, your stream one is broken, then what it will do, it will do the stop. It will do the retry for a certain time. And let's say if that retry with the source ID and destination ID. So it will all the time, it will ping to the source ID. Oh, are you available? Are you available? So after ping to the source ID, it will get the status that, okay, is the source available? Is the destination available? Once after, like in the retry cycle, when it get to know that, okay, this source or ID, the source ID and this destination ID is again available over the internet, then I will reconnect them and reinitiate the remaining transfer. Reinitiate the remaining transfer. So in this way, QUIC is able to handle the scenario where you are getting disconnected from the internet or something happened. It might be possible that your network just got switched from 5G to 4G, 4G to 5G, and these things happen. Like right now, we are living in a days where this thing happens so frequently because it might possible that you are moving in your car and you are using something very uh, let's say you are watching movie, you are listening some song, and after getting connected again, you are getting streamed again from the same place where you left. So this is the logic behind it. This QUIC. This QUIC is enabling you to get the data from where you have lost it. And how it do this thing. Again, we are going little bit more deep. Till now, if you are fine, then it's fine. But I love to teach more deeper way. Okay, so let me show you a bit more deeper knowledge about it. Again, we will start from the user. Okay, where is the byte? Here is this. So here is the user, and here is the application. So we will track about like what in actual it happens. So when users send data, okay, there is a one offset terminology. What is this offset? I will explain you. So for that, let me just create one scale here. Okay. Let's assume it is one scale, and let's assume it is second scale. Let me mark this one. Okay. So it is 1,000, it is 2,000, it is 3,000, and so on. It is 3,000, and so on. This one is from the user side. This one is from the application side. Okay, so we have these two scale, and why I created it, because let's say user is sending some data to the application, and this user, uh, as I told you, that particular data, it will give the application that, okay, I will going to start to send the packet, which will start from the 0. Okay, so it is the packet 0, it is the packet 1, it is the packet, it is the packet, and it is the packet 2. These packets are the packets which will contain the actual data. It will contain the actual data. And this data is going over the QUIC. So I have these many packets, and these packets will, okay, where it is the glue in red. Okay. So these packet will go to the application one by one. First 0 will go, then first will go, then second will go. And let's suppose something happened. This P0 reached here and this P2 reached here, but this P1 get lost in between the transaction. What this QUIC will do to the application side, it will let the another P3, P4 to the reach to the application side. So right now, this application will have all the data till P0 to P3, but it will not have the data P1. So what this application will do, this application will send back the acknowledgement that, hey, okay, I got these packages, but I didn't get the packet P2, sorry, P1. I got P0, I got P2, I got P3, but I didn't have the P1. So what this user will do, okay, so, okay, fine. If the P1 is not reached, I will send the P1 again. Let me just switch back the pen. Let me just switch back the pen. Okay. So what it will do, it will send back the P1 again to the application, but this time this application will receive it as P4. So you will think that, okay, I got the P4, but the P1 is still missing. How the application will form my data? Form my data, because that data is connected to each other. Like the data is in a sequence that 1 will come after 0, 2 will come after 1, 3 will come after 2. How this P4 is going to integrate with the existing data with like this P0, P2, P3, because it should be placed at the P1. So this QUIC provide one mechanism of the offset. What this offset will do? So with the every packet, it will send one offset range also. So let's say at the packet 1, the range is 0 to 1000. At the second packet, the range is 1001 to 2000. At the third packet, 2001 to 3000, and so on. This is for the P1, this is for the P0, this is for the P1, this is for the P2. So it is the user scale, this one. So what this user did, it created the complete scale of data and it divided that data into the offsets. Now, when it reached to the application, these packet this application will open these packets and it will read the data of offset. So this application will maintain a scale to this one. This one is for the application. So it will find that, okay, I have the data from 1 to 1000. I have the data from 2 to 2000 to 3000. And in the P4, I got the data of 1000 to 2000. So in this way, it will insert that data into the right place and it will form the complete package which you want to send over the QUIC to your application. It was the flow. It is really amazing that how people can think this much. It is easy, it is complex, but it is the way we all are using internet in nowadays. So in this way, this QUIC work. So let's do one comparison. Again, it is a good comparison between these all the three things, TCP, UDP, and QUIC, so that we can remember that, okay, what we have learned, and I will tell you few more new things. Okay, so let me just scroll down a bit. Okay, fine. So what I will do, I will just create one table. It will be for TCP. This will be for UDP. This will be for QUIC. It will do the three-way handshake, no handshake. While sending data, just fire and forget. One-way handshake. The way we did the three-way handshake, actually that is called as RTT. RTT is what? RTT. RTT means is round trip time. So for the TCP, when this acknowledgement and synchronization is happening, then one RTT is spent. For the UDP, it is 0 RTT. For the QUIC, it is, I guess, around, it is also 0 RTT. Don't get confused. Somewhere, if you read this 3 RTT for the TCP, that is with the TCP plus TLS, then you will get 3 RTT. It is really uh, I will say that you should remember it when it comes to TCP plus TLS, then it is 3 RTT. But we are only talking about TCP right now, so it is only 1 RTT. So this RTT is nothing, just a time uh, between the source and the destination. Let's say if it is 300 milliseconds, so it might take only 100 milliseconds. This will also take only 100 milliseconds because either it is going one way, but it need a complete cycle. This TCP need a complete cycle. So it will go to the server, then server will send something to the user, then user will send something to the server back. So this will cost 100 milliseconds, this will cost 100 milliseconds, this will cost 100 milliseconds. It is, I'm just giving you one time frame. So this particular acknowledgement will take 300 milliseconds. UDP will take no time because no handshake, so directly sending the data in 100 milliseconds. And QUIC is also doing the same, but with the reliability also with the 100 milliseconds. So in every way, this QUIC is the winner over all the things, this TCP, UDP, QUIC. But still, there are so many applications which are still using the TCP. They are not moved to QUIC. But still, QUIC is good, and I will recommend you to use it. But when it comes to the financial transaction or financial app, I will still stick with the TCP because I want everything to be systematically provided to the bank server. Not everything should go over the QUIC. UDP, you can simply forget. If you are going to use UDP, you can simply switch to QUIC. But TCP is still good. TCP is providing you the reliability. This is a one more feature which I didn't talk about this TCP. As I told you, for the user and server or application, if user is sending something to the application, let's say data, and this data is missed, let's say P1 packet, P2 packet, P3 packet, it all contains the data. P1 reached here, P2 got missed. P2 didn't reach to the application. So application, what in TCP happen is, for each packet which you send to the app send the acknowledgement back to the source. So for each packet, when source is sending data to the application send back to the acknowledgement. So let's say this P2 is going there and it didn't reach to the application. It means that application will not send back the acknowledgement. And in case this timeout happened, then source will again try to send back the P2 packet to the application. And it will not send the packet P3, P4, P5 until the P2 is not placed at the application. So these many things are there. That is why this TCP is so reliable, because it ensures you that yes, Your each packet is reaching to the server in a systematical way, and I'm giving you surety that none of the data is lost. Okay, so we talked about this a lot, and now let's move to the part where I'm going to show you how you can code this thing. Also, it's a very small snippet of the Flask application. So here is the code for the TCP. It's just a simple, a very basic app from the Flask, and how I'm ensuring it that this Gunicon, when you are running it from the Gunicon handle the TCP handshake and worker assignment. So in this way, you are just going to start the communication between your user and application through the TCP. But also there is a one socket way, which you can directly import the socket library, and you can use its module to make sure that your application is using TCP if you are not going to use Gunicon for your application. Let's come to the UDP. Again, as I told you, there is this socket which you can import, and this socket is provide this create a UDP socket. You just need to provide the sock underscore dgram. This sock underscore dgram will provide you the uh, UDP protocol connection between the user and application. But if I just do the full stop, so all you need to do is you just need to go and you have to select the sock underscore where is that sock underscore sock stream. Okay, all you need to do is you need to select the sock underscore stream. Now what it will do, it will start the connection between your application and your server, sorry, application and the user. They will talk to each other with the TCP protocol. So with the earlier implementation, this sock underscore dgram, it will use the UDP. Now let's come for the QUIC. For the QUIC, there is one Python library which is called the hypercorn. This hypercorn will enable you to use the QUIC protocol for between your user and your application. So this is it for the side of code as well, because we need to understand that how it is implemented, so that if we are going to implement, then we can establish a connection when we are starting the server. So later then all the connection happening or all the data transfer happening with the way we want it. Okay. So it is the second thing. Now let's come to the last part where we are going to discuss about the system design interview question. So where is that? Okay. So here is the TCP, UDP, and QUIC, three questions. Its answers are present into the description, but still we will go through the questions. So you are building a real-time AI voice assistant that needs to work over mobile network. A user is walking and their phone switches from their home Wi-Fi to cell tower. In TCP, the call would drop. Why does QUIC allow the call to continue without a new handshake? So we already discussed that this QUIC will store the mapping of this connection ID and the destination ID, sorry, the source ID and the destination ID. And when it is dropped, it will do the retry mechanism on it. And when it do the retry mechanism, it will just try to let it come to the internet, this user and the application. Once they both are available, again, the same ID will establish the connection with each other. Okay. A user in India is accessing an AI server in the US with the RTT 200 milliseconds. If you are using TCP plus TLS, how much time passes before the user's first AI prompt actually reach the server? How much time do you save by the switching to QUIC? So as I told you, if it is only TCP, then it is just one RTT. But when it combines with the TLS, then it becomes 3 RTT. So here, again, it is the TLS 1.2. It will cut one cycle. Sorry, it will not cut. That is with the TLS 1.3. Don't worry, I will teach you about the TLS 1.2, 1.3, everything. But currently it is TCP with TLS 1.2. It means it will become 3 RTT. 3 RTT means 3 multiplied by 200 milliseconds, it means it will take 600 milliseconds for the AI prompt to actually reach the server. How much time do you save by switching to QUIC? As QUIC will take only 1 RTT, so it will take only 200 milliseconds. So you just divide it, or sorry, you just cut the time between the transaction of data to 1 by 3. Okay, so let's come to the next question. Your AI API sends a large system message, stream A, and a short user response, stream B, at the same time. If the packet containing the beginning of the system message is lost in the transit, does the user have to wait to see the user response over TCP? What about over QUIC? As I told you, when it to the TCP, user have to wait for the stream A to be completed because stream B will be in the same pipeline, but it will go in the sequence. But for the QUIC, there are multiple streams which are running parallelly. So stream B will be completed and stream A will send the packet again after getting the acknowledgement and offset data. And based on that, it will complete the request too. So that is it for this video. And I hope that I have provided you bit clarity that what is this TCP, UDP, and QUIC, how you can use it in a code, what are the questions we can get over the interview, and that's it. So in the next part, we are going to talk about the TLS, and we are going to talk about the HTTP. We are going to make our communication secure. That part is still pending. Okay, so we will talk about that in the next part. And thanks for watching. If you like it, then please share and subscribe it, and let me know in the comments if you have any questions or you need any improvement in this part. Thank you.